the following. Again, you don't need to read the proof in detail, but I put it here so that for those who want to know, you can study. For example, limit is always unique. That means you cannot have this thing, limit equals 7, and then limit go to 8. Don't tell me, oh, this is trivial. No, you need to prove it. How do you prove it? You prove it by contradiction. You prove there exists two limits. And then these two limits are not equal, right? And then lead to something crazy, then done. So this is what I do. So I said that you have an L, and you also have an M. You have two numbers, L and M. And then what? Because of L, you have this sentence. Because of M, you have this sentence. Okay, now work from here and here to derive something wrong. What I use here is triangle inequality. Play with absolute value, which give me some error. You read it by yourself in detail. And then I have a contradiction. That means what? L and M are near to each other. For epsilon, any epsilon, that means including 0.00001. That means it should be same. But as I said, they are not the same. So that means everything here is to disagree with this guy. So the negation of this guy should be true. That means L and M should be the same. Okay? This is a proof by contradiction example. And with the same kind of idea, you can prove if you have two functions, f and g, if they both have limit, then the sum limit of f plus g is the same as you split the limit here. This is exactly the same thing as sequence. And you have a constant here, you can take the constant out, and if you multiply them, it's the same as you have the product. And if you have division, the same as you can get this inside. Of course, this guy cannot be 0, and then you do the same thing. So it's the same. Everything is the same as the sequence version. Equivalence of a limit of function and limit of sequence. So let's say this is my function. What's the sequence? Sequence means I can only take integer 1, 2, 3, 4, 5, right? So this is n axis. And this is 1, 2, 3, 4, 5. If I take sequence on this f, I only see this dot, this dot, this dot, this dot, this dot. I don't see the whole line. What I'm saying is that if I consider convergence of the red curve, it's convergence in limit of function. It's the same as I consider the limit of the blue dot. That means limit of a sequence. They are the same thing. How do you find the limit of this thing? First, what I'm going to do, I take out the e to the power 4x, then I have this, okay? And then because of log, I can split this two, because log AB is log A plus log B, right? So I have this. And then because I do natural log, so the e and the log cancel out, I only have the power. So now I have this. This is just what? FG. So I can apply. If I have a fraction, I can put the limit, go inside. So I'm going to put the limit, go inside. And then here, what I'm doing is I multiply the whole thing by 1 over x. So now I have 4, 2, okay? And then I can, of course, again, put limit inside. And I just jump step. In principle, you should not jump step. You should understand why you can jump step. But I'm lazy, so I jump step. So this guy is 0, okay? And then